Live from the internet, it's the Localhost podcast with Mark Drew and Rob Dudley.
Hello from the internet. We are your guides to various aspects of the lovely world of web development. Every month we shall get together and discuss an aspect of web development. We shall try to unwrap the subject using questions sent by you, the listener. That's right, we shall be answering your questions every month. You can contact us via Twitter at localhostfm or email your questions to show@localhost.fm. I am Mark Drew, and stepping up to the challenge to answer these questions with me is Rob Dudley. Let's get on with the show. Hello! Hello, Rob. How are you doing?
Hi, Mark. I'm good, thank you. How's things over there?
Fantastic. Very exciting to get started with our first episode.
This is it. Episode 1? Episode 0?
Episode 0. Well, let's start counting from 1. I don't want to start doing 0 arrays here.
Okay, so what are we going to be talking about today?
So I've titled this episode Dr. Docker, I presume, and basically we're going to be talking about all things Docker and containers. I guess we better start the show by saying WTF is Docker. Let's talk about what is Docker. Oh, containers, the cloud, Elastic, etc. So, Rob, do you want to fill us in what Docker is?
I thought you knew.
I know a little bit, but I thought I'd pass it on to you.
Right.
I'll talk to
Docker is a way of containerizing your application, right? So that we can effectively deploy and run the same application across different machines with the same set of configuration and what have you. I suppose the key takeaway has always been rather what the hell is Docker or what the hell is containerization. How is it different from virtualized machines, VMs, virtualization?
Yeah, I think we'll get into that. I think the best analogy I heard from this was, I don't know if you step back in time to the 1800s, right, and you had a piano. Can you imagine a piano?
Yes, I can.
I'm trying to send a piano from London to, let's say, New York. So what will happen? It will come out of my house. 5 guys would, carry it across the street to a cart, I presume. They'll log it onto the cart, they strap it down, and they'll basically have to take care to take my piano all the way to the States, to an apartment in New York. And there'll be various ways of moving it around, right? So there'll be people like sliding it up, being careful not to touch the keys and stuff like that all the way across the sea. And this obviously doesn't work very well because, for example, if you're exporting, I don't know, coffee next to bananas, I don't know, mainly, as you would, right? Because they come from warm climes. But the smell of coffee would go into the bananas, or vice versa. So you have banana-flavored coffee, because you'd have these sacks of coffee next to these, I don't know, punnets of bananas? What do you carry bananas in?
Crates?
Crates of bananas, that's more logical. And then they came up with this idea of containers. Like, they thought, well, why don't we create this box that everything fits in, is the same size, so it means that doesn't matter if you're carrying a piano, bananas, or coffee, you can put it all in the same size and you have the same equipment to carry it around. So if you imagine these big docks like Rotterdam or even the Port of London, you've got the same machinery to unload these ships. But you don't care what's inside the container. It can be a car, it can be a banana, it can be a piano. But you've still got the same equipment to move it around rather than guys with straps and wheelie bins and various different ways of hooks for meat or things like that. Fun trivia fact: a container, an actual container that is frozen, is called a reefer. There you go.
Good to know.
A refrigerated container. So taking that concept forward to software, the whole idea is that sysadmins don't have to care what's inside the container. They can just deploy it because there is a standard way of deploying your application.
Yeah, so presumably
or running it, I should say.
To extend your kind of metaphor, the donkey cart with the piano on it might be like the zip file that contains all of your source code and assets, and it kind of works as a way of getting your application around, but it's a faff and it's very involved and what have you, whereas containerizing an application means that actually it can just be delivered, picked up and run without any fuss at all from any of the parties involved.
Exactly. So that's kind of what Docker is as a high-level overview. Shall we get on with questions and see if we can delve deeper into the subject?
I think we should.
All right.
Let's see where this takes us.
It's your questions, it's your questions. It's your questions, it's your questions.
So we had the same question twice from two different people. Well, they each submitted it once, and it's like, just why Docker? Well, why not? But
I think can we get the obvious one out of the way first? Because it's new and cool. It will earn you hipster points, right? This is full-on startup buzzword bingo aces.
Right. And that's the important thing in web development at the end of the day. We have to have new and cool stuff.
It's an important thing, right? But there is a reason that it's become new and cool, and there's a reason that it's risen from pretty much obscurity into common usage around the web. There's a reason we're having this podcast episode. It's the reason it's our episode 1. So why are we talking about Docker? Why is it as popular now as it is?
I think it's one of these pain points that we keep on solving, right? There's various pain points in web development that we solve. Like jQuery solved a whole bunch of problems with the web. I mean, now I know I don't want to get into the JavaScript episode yet. But before then, it was a real pain to develop and do things consistently and easily. And one of the big pain points about deploying was, well, now with the cloud, how am I going to deploy stuff that I'm doing on my machine? And how am I going to deploy that then to EC2, which is a completely different environment? So Docker is a way of being able to take away the detritus of applications and actually focus on my application and how I stitch these things together, and there's a common way of stitching things together. So why Docker? Well, it's popular, as you say, and also it's the new way of deploying the stuff in this new cloud-friendly era, I guess. I
think this is the big takeaway is there are two main touch points for me. And both of these have potentially been solved before in different ways, and Docker takes a slightly different approach. Containerization takes a slightly different approach. So you're absolutely right. Being able to easily deploy in a standardized fashion and deploy across providers, right? So I can take this, I can deploy it to AWS, I could deploy it onto Google's Cloud Engine, other cloud service providers are available. And exactly the same information is flowing out of me, the same container config and what have you, and I don't need to do anything different. Right. The other thing that I absolutely love about Docker is I can also deploy into my development environment. I've got total consistency between what I'm working on when I'm developing, maybe my staging environment and testing QA and production. And this is one of those things that people who perhaps undervalue this as a point have never been bitten by a difference in development and production environments. They will be at some point, and it will hurt. And they will cry and think, why didn't I listen to Mark and Rob when they told me that I could have used this to prevent that?
Exactly.
But yeah, so I think it's standardization and ease of deployment is absolutely brilliant.
Awesome. I think, and this actually brings up the next question, which is, how does Docker compare versus traditional VMs? Because people might be thinking, well, you're talking about a VM, right? It's a whole machine that you've wrapped up. You know how to start these VMs that are, a couple of gigs big or something like that?
Yeah, but is it though?
No.
That's the thing. Is it a virtual machine with a fancy name and a cool icon? No, it's not. Why is it not?
Is that a question for me?
That's kind of a question for you.
Yeah, right. Are you passing the ball over? Well, the VMs is basically a whole machine that you start up, right? So, for example, on my Mac, I can have a Windows VM, I can have a Windows 10 VM, I can have an Ubuntu VM, all running at the same time, and they're all taking up a percentage of my resource, which is not just what they're doing, but it is literally like I need to start up the whole kernel and allocate RAM to it and stuff like that.
This is it, right? So a virtual machine is literally that. It's ring-fenced resources, so it needs a certain quantity of hard drive space, a certain quantity of RAM, and this is what you need to run the entire operating system. So those numbers are potentially quite big.
Right.
Yeah.
So with 32 gigs of RAM on my machine, I can probably run 4 big VMs.
Yeah, and however smart the kind of VM layer might be, the hypervisor might be at swapping this and managing it, fundamentally you're pretty much limited to the resources you have divided by the number of machines you've got or need to run. Tells you just how much resources they can have, because they pretty much need it, they own it, they grab it, they keep it.
Mm. Right, and so how Docker differentiates itself from this is that it's more like it's like a process, actually. It's like and the process is only going to be what you're running. So what it does is it takes slices of the OS. So usually is, for example, I was running one machine, and that was a whole bunch of images that make up the layers of that machine, and we only run what we need to run. Does that make sense, Rob? I think
it kind of does. I mean, to take it another way, the example that I've always been given is virtual machines are whole machines. They have their own kernel, their own memory management, and what have you. What Docker actually basically does is it shares a kernel.
Right.
Which means that what you're doing is you're sharing access to everything that the kernel does. Memory management, network interface, and what have you. So rather than having to load all of this stuff every time for every machine, by sharing it, you only have to incur the overhead of running that once, which means you get much better efficiency, you get much closer to the actual underlying hardware or interfaces, so potentially you get better performance. Yeah. It does come at a trade-off, right?
Okay.
You'd get worse isolation.
Right.
And by and large, this is one of those problems that unless you are massively, massively concerned about the kind of high-level information security requirements of your application, is not a problem for you. But it bears stating the potential for Docker containers to kind of leak information and be accessed by other containers is there in a way that it's fairly heavily removed from virtualized machines. You know, they're very quite tightly ring-fenced. But, as I say, this isn't a problem for 99% of the stuff that we do.
Right. I mean, I think one of the things on a podcast we can't really show very well is how fast it is to start up a Docker container. For example, if I had a VM running Lucy, the CFML engine of choice, it would take, a few minutes for, let's say, Ubuntu to start up. And then to start up, the Tomcat, for example, right?
Yeah.
Now I start up a Docker container with Lucy, and all it starts up is Tomcat.
That's it, straight up.
And it's straight up, and it's actually, weirdly enough, I don't know which voodoo it does. It actually starts up a lot faster than it does on my host machine, which I still haven't quite figured out why. Maybe I'm just assigning less memory or something to it. But and also the fact that Docker would be running on your machine in theory, right?
Yeah.
You'd still have, even in the cloud, you'd have a EC2 instance that you're running Docker on, which your machines would be running on. So it would be your machine. So you're right that it kind of shares memory and resources, and part of that there is a security aspect. But at the end of the day, it should be running on your machine or your elastic container, so to speak.
That's it. Yeah, you should totally be satisfied that the operating system or the machine that's running Docker, that's running all these containers, you control and you own. So, as I say, the security risks are minimal. I mention them only so that I don't get some InfoSec bod on Twitter just like, data leakage.
Right.
I think the other thing is that, and hopefully by this point we've made this clear, because this was one of the most confusing things to me when I first started using containers, and everybody was saying, oh yeah, you can run containers on EC2. I'm like, well, hang on, wait, what? I'm virtualizing on a virtual thing?
Right.
Wait, check your totem, dude. This is full-on Inception. But it's not virtualization.
Yeah.
So running Docker on a cloud service provider, running it on a virtual layer on your own machine if you need to, if you're on Windows, Mac, not so much now, but in the early days, Docker was Linux only, right?
Right.
So you'd often spin up a virtual machine, install Docker, and then profit. But it's not the same as the nonsense that you'd get virtualizing virtual environments within virtual environments.
Yeah, that's just far too Inception for me. Let's get on to the next one, which I guess is from Dave Ferguson. Dave Ferguson is from the CFR podcast, so it's a great
Dave.
podcast. It's a wonderful podcast. Hello, Dave.
I listen.
Yeah.
Yeah.
So he had quite a few questions, so I've put them all together. But one is, he's intrigued by Docker and about environment-specific builds. So I think he was saying, like if you've got a legacy system that has that your app depends on a specific environment, how do you deal with that with Docker? What do you think?
How do you deal with it currently? I suppose would be, not to answer a question with a question, but I mean, sure. Docker provides you with the ability to fundamentally introduce a level of configuration and kind of scriptability to your deployment of your container. It also then goes on to allow you to extend that scriptability if you wanted to use something like Ansible or Chef or Puppet or what have you. You can introduce all of those as additional layers on top, right? Now, ideally, if you're using containerization right and well, you should end up with something that you can just rerun, or you can tweak to hit your different environment requirements. Now, when we look at, say, for example, let's take a ColdFusion container, or to flip it on its head, because not everybody's using ColdFusion, sorry, Mark. We could also look at, say, Python. Both of those systems have different approaches to how we manage the environment. Python's got a really solid system like virtualenv that lets us basically pre-specify. We install a couple of bits and it's kind of baked in. ColdFusion, we're probably going to have to do it more manually. If we've got a system that needs to be deployed onto version 9, which is totally out of support, but hey, or it needs to be deployed onto a specific version of Lucy, or it needs specific Java classes to be loaded in, or what have you, we're just going to script those into the deployment. So that when we build the container, when it first executes and spins up, those things are set up for us. The nice thing about the Docker layering is that actually we can do that, because when we tear that container down, it's clean, it's gone, and then the next time we spin it up again, it does the same work items to configure our environment.
Yeah, I think that's a good answer. I think some of the questions that people come up with is, well, I install IIS, I install, let's say, Tomcat or ColdFusion, whatever, I don't want to be specific to that. Mm-hmm. Then I install MS SQL, and then I have to put this other bit of software that makes my life better, whatever, a PDF converter, as an example that I hear all the time, right? But I think you should split that out. Generally, you split it out. I see containers work well with other containers. I don't want to get into containerception here, but for example, with Docker Compose, you can actually say, this is my web layer, which just deals with the website stuff, and this is my database layer. And actually, you can have a Docker container for your database, right? And then you can have a load balancer layer or front-end web server layer, which just does the front-end web serving and just connects to the back end. So you can define your environments much better, and they're reproducible, because you can actually have a load balancer in front of multiple instances of your application on your development environment. So you can test what happens in a load balanced environment, which, to be honest with you couldn't do that before. No. Or it took a while, right? It was a pain to set up.
And then you'd get home and change Wi-Fi networks and have to reconfigure it all.
Right, yeah.
Yeah.
Right.
So I think that actually that's a really core point, and it speaks to, I suppose, suitability, which I'm guessing is probably going to come up in a later question, but I'm kind of going to run ahead of ourselves here, which is to say that actually if you've got this giant kind of big ball of mud, everything on one server application, you can absolutely do that straight into Docker. It will suck. The experience will be absolutely shocking. You will hate it. You will probably curse our names and never go back. The reality is, you need to separate out your application along these logical layers. Where's my database? Where's my web? Potentially, where are my static assets stored? Can I easily create persistent machines rather than those that are potentially a bit more temporary or transient? And these are, generally speaking, fairly small changes that you can make. Maybe you have a web layer that just writes all of the uploaded documents to a specific folder. Fine, make that folder a network share. You know, just mount it and have that on a different machine, because then you've got flexibility and separation.
Right. I don't want to throw a spanner in the works, but one thing that blew my mind was that you use a Docker container to map to the host drives.
Yeah.
Because then you can actually replicate that mapping all the time, because you've got a container that has a definition, and it's actually not heavy. It's not like another massive stack, because you share layers between them.
No, and also going back to this thing that it shares a kernel. The kernel that's running Docker is also the kernel that's running the native file system, so it's as quick to write back, right, as if you were writing on the local machine.
Exactly. Okay, let's go to the next question. How does Docker fit into the development workflow? This is Dave Ferguson again.
Well, you turn it through 90 degrees, and then you kind of give it a little shimmy, and then it just slots right in.
Right. Well, actually, I set this up very recently for a client. So we're moving to Docker for the whole environment, and they've got a very big, complicated environment. So different bits are going into Dockerized situations, whilst we still retain a lot of the legacy system. I guess you could call it legacy. Let's call it complicated more than anything else. So what we're doing now is I use it as a replacement to Vagrant. So we have the image which actually runs Lucy. That's all it does. It only has Lucy configured in it, and that points to a volume on my machine, which is my development folder, right?
Yep.
When we commit stuff, we then actually have a script that then goes, checks out our code, bundles up, builds a container from the source code, and then commits that into the repo, right? And then we have another Jenkins job that then pulls it out, runs it, and runs the tests on it. So it fits in like 3 different places, as well as the live environment. And this is kind of the point, right? So I have my dev environment that's identical to my test environment, which is identical to our production environment. So it fits into various parts of it, I guess. It's actually like right from the core part of it as well. But there's two things here. One is I'm running code that changes. In other words, I'm mounting my local development folder, so with my source code in a development environment. But in a test environment, I'm wrapping that up into a container, which is an extension of my original container. Does that make sense? I think
so. Yeah, we're approaching containerception, but no, I think that's pretty clear. I mean, I suppose the other thing I would say, just because you started with it's a replacement for Vagrant, and I'm guessing that everybody listening has a vague clue of what Vagrant is. It's scriptable, redeployable, but it is virtual. If you're using Vagrant, or even if you're using kind of some crappy homebrew VM where you're passing disk images around, you will actually find it much simpler to integrate Docker into your development workflow, because you're already used to this idea that you have this kind of standardized container. The people I find who will struggle the most with implementing this are the ones who are actually just running the server on their own dev machine. You know, they've got iOS installed, or they've got Apache or whatever. They've got the language of choice in that current binary for that current operating system, whether that's Mac, Windows, Linux, whatever. Now, for those users, it's going to take a bit of work. You're going to need to make a bit of a jump. You're going to need to change some habits. And you're going to need to start thinking about, actually, okay, how can I deploy this? How can I package my containers on commit? All of this is good stuff, right? And it reaps massive additional benefits down the road, which I'm not going to talk about now, because I'm pretty sure we have an entire podcast on some of them coming up. But yeah, it will mean that you need to get a little bit out of your comfort zone. The benefits, however, are huge. I mean, the best example I can give you is a few weeks ago. And this really happened, right? I spilt a glass of water on my laptop.
Oh dear.
Yeah. And it went kind of fizz pop, and I took it to the shop, and the guy said, yeah, that's gone. And I was like, okay, fine, can I get a new one? He was like, yeah, I can. And because we're in Jersey, and Jersey doesn't have an Apple store, and it takes basically a millennia to get anything shipped over. So I'm sat here thinking, well, great, I've got to go to work, I've got stuff to do, and because all of my dev environment was containerized, spinning it up on another spare machine that I just happened to have kicking around took about 15 minutes.
Wow. And that's it, isn't it? Really, that's...
Yeah. It was the most painful situation I've been in from a work perspective. So, and again, this happens. You bring a new team member on board. You don't want to be spending half a day configuring their dev environment and getting all the packages lined up, and then realizing that maybe some of the packages have been deprecated. And
they might not work for his machine, right? So there's a guy at work that runs Ubuntu, and you're saying, run this system. But I don't have the Mac drivers or whatever that needs. There's another aspect actually about Docker that I found really, really cool. So when you install Docker, you get the Docker daemon that kind of runs in the background.
Docker-D.
But also you got Matic, which allows you to browse different software or search for software. And the great thing is, like, I want to use MariaDB, for example. This is just a recent example, or Redis. Before, I would have to install it on my machine, and then for some reason, even to this day, on this Mac, I happen to have another login for another server that was for installing PostgreSQL. And I was like, why have you changed my machine? I only wanted to try PostgreSQL, and now you've actually changed my physical machine. Now you don't have to do that. You just go and Docker run PostgreSQL. There you go. You have a PostgreSQL instance running on your machine without having to install any software.
Yeah, and all of this stuff is available in, there are a bunch of different kind of container directories, right? So gone are the days of having to run 3 different database servers, 4 different cache servers, and what have you. There was a ridiculous point where I think I was running Redis, Mongo, Postgres, MySQL, MariaDB, and Memcached. And they were all in my development environment for different projects. And I was like, this is insane. I have got so many different ways of persisting data on this laptop. So being able to say, actually, Docker, for this project, I need a container that has this, and even down to this version of this database.
Right, because have you had that problem that you've got like drivers for one version of database, but your project is actually using a different kind of database because they happen to run it on a certain version?
The one that got me was different versions. We're running, say, MySQL 5.7, which I think is current. Is it 5.8? Either way. And there was actually a project that I was working on that we couldn't run it on 5.7. It needed some work. It needed some refactoring to get it to work on 5.7 because of some changes and what have you. Basically, I could not run both projects at the same time on the same machine. It wouldn't happen. Being able to have a containerized 5.6 database, 5.7 database, and they come up, they're brilliant, they're happy.
Fantastic. Let's move on.
What's
onwards,
next?
McDuff.
What have we got?
You're going to love this question. Does CFML work? How about Adobe ColdFusion and Lucy?
I assume this is in the context of containers, right?
Right.
Not more generally.
They don't do that. Yeah, I think they've been proven to work. I think a couple of websites are running it.
Yeah, just a few.
Just a few. I run it. The difficult one about Lucy has already got 2 containers, 2 images, so you can have Lucy 4 and Lucy 5. They're already on their GitHub, so github.com/Lucy. You find the Docker images, I think it's called. I can't remember. Lucy Docker images, and if not, you can find them on Matic. I actually have my own versions in my Docker Hub, which is kind of like a repository of all the images, because I like to add, I like to add MongoDB because I use it quite a lot, so I already have the extension installed, ready to go, So with Lucy it does work. With ColdFusion it's actually easy, but it's difficult to replicate for the world. So I was able to do an image. So basically what you can do is create your own image and say, all right, I've started up Ubuntu, for example, right? And then you can actually download ColdFusion and install it on that machine, because you can connect to that machine, attach to that container that's running, and you go through installing your version of ColdFusion on it. And whilst that container is running, you can then actually commit it. In other words, create an image of it, right, and save it locally. I think the only problem with Adobe ColdFusion is doing licensing, so you can put your images in somewhere public.
I was going to say, this has always been the problem with, well, not always been, that's a bit harsh, but yeah, commercial software and containerization or even virtualization and redistribution is kind of a bit of a sticky point.
Sure. But you can have your own repositories, right? Because like Docker images are like version control. So I should point that out, that you can check them out, you can run them, do whatever, but you can also then commit them to your own repository. So you have your own thing, your own version of the software. But you can also have private repositories, like AWS has repositories in there, because obviously you don't want your software going out to the whole world.
I think most of the big repository suppliers actually give you the option to toggle it on or off.
Right. So you could... the only problem was doing it as a public image for everyone to use. And that's just a matter of me talking to Adobe saying, hey, can I put this on here? There's no configuration changes. And it's that redistribution problem. But apart from that, you just go and install it and then save it as a new image and tag it as, like, I don't know, Mark Drew's Adobe ColdFusion 2016. And then you can just start it up and it'll be running. And then you can configure it, save the configuration, commit it, and push it to your repository.
Can I ask an awkward question?
You can.
Obviously, CFM and Lucy both JVM backed.
Right.
And this might be about to go off on a bit of a tangent, so feel free to just kind of make a note. You can edit this out later.
Okay.
JVM is already a virtual machine, right?
Kind of.
Kind of. And we've already got the facility to package applications that run on the JVM. So I suppose, why would I look at using something like Docker when actually I can just have Tomcat already up and running and just deploy my WAR file straight into it? I've still got that standardized layer of stuff. It's all still the same, in theory, run everywhere, right? So playing devil's advocate here a little bit from my perspective, but for JVM specific applications, Docker, justify yourself.
Well, I can't talk about JVM specific apps, because what you could do is actually have your application already like an uncompressed WAR, right? Already deployed to Tomcat, and you're done, right? And you're just running it within the container. For stuff like Lucy, you can do a couple of things. One is you can pre-compile all your code. I think you can do that with ColdFusion. I haven't done it myself, but you can already pre-compile a mapping and just say this mapping is compiled, and it'll be nearly the same. The only difference is that Lucy compiles on the fly and it has its own class loaders. So back to your question, is the JVM already compiled? You can do pre-compilation on it and it'll be the same. It'll be just hot running code rather than compiling code. Does that answer your question?
Yeah, kind of.
Okay.
I mean, I suppose the other thing is there are all of the other benefits we've already talked about that will still bite you in the arse, even if you're running like a JVM-based thing. It's not run once, run anywhere. There are dependencies, there are differences in operating systems, file paths, connectors, drivers for databases, and all of this, all of which Docker allows you to actually enshrine and contain in a much simpler way.
Yeah, I mean, if you look at, for example, Lucy, the Lucy images, that extends a Tomcat 8 Docker image, which then extends the OpenJDK image, which then extends, I'm trying to remember which one it extends down to the base Ubuntu image, I think.
It's either Ubuntu or Core, right?
Yeah.
But that's that's really, really important. Something you just said there that we haven't made clear yet. Yeah, you get extension. You effectively get inheritance in your Docker containers. And
you try to use it as much as possible as well, because
totally.
It means that you don't download new images, right?
Yeah, and it also means that actually you get the benefit of upstream kind of tweaks and tidy ups and what have you, and they just come in naturally. And you can do all the things that you'd expect, like pinning versions and what have you. But it does mean that you're not having to sit there and actually create your container from the ground up. You're not crafting this from the kernel up. You're saying, actually, this is where I'm starting. What do I need?
Right, so you can say I'm starting from Tomcat because I'm writing a little Java app and a JSP, and I want to run this JSP. So say I want to start from Tomcat, which actually comes from OpenJDK as an example, or I want to start with Python, and Python needs whatever it needs, but you can actually just say I just want Python. That's all you get, even though you'll download a whole bunch of other images that then can be reused amongst other different containers and images.
Yeah, and that's the thing, because then you can define your own kind of base image that actually already extends a whole bunch of this stuff. So you might have the Lucy base image that then an organization takes in, makes a few changes to, adds another layer, and they're only dealing with their changes to it, and they can distribute that internally or what have you. We kind of got a little bit off point, but I think it was valuable stuff. It was good stuff.
It was good stuff. So now here's a tricky question. Ryan asks, how about with Windows? Well, actually, okay, so you can run Docker on Windows.
You can run it on Windows.
Right, but what you'll be running is a JVM, not a JVM, a VirtualBox instance of Ubuntu, which will have Docker on it.
Okay, why is Windows and Docker, why are Windows and Docker not sitting in a tree?
Well, actually, there will be.
Okay, seriously. Let's answer the simple question first.
Okay.
It comes back to the fact that Docker currently uses para-virtualization or kind of kernel sharing technology that was originally invented for the Linux operating system, right? So you've got, is it LXC?
Not sure.
Either way,
I'm a higher level kind of guy.
Yeah, so am I. But it comes down to actually when you take the kind of you lift the bonnet, lift the hood for our American listeners on Docker, and underneath that, what you've actually got is a bunch of Linuxy technology that are all to do with sharing kernel space in kind of safe jailed areas. Originally, Docker was only using one of these, which was Linux only, and the Docker team have been working really hard. They've extended it out. You can now choose between, I think, 2 or 3 different variants. But what they haven't yet managed to do is get a native Windows version of that kind of Linuxy kernel sharing thing.
Right.
Now, this, I assume, is where Mark is about to tell me, well, actually, they are doing it, or they've done it.
Yeah, they are doing it. They're doing a headless, UI-less version of Windows for exactly this purpose. I think it's in beta. People are going to be shouting at me and telling me that I'm completely wrong and I've got the details wrong, but I'm a Mac guy, so I don't...
Well, I tell you what, let's say this is one time when I will invite people to shout at us. I will say, actually, please, because this is an area that I don't know anything about. I work on, our production stack is Linux, my development machine is Mac, and what have you. So it would be really good if somebody's got a bit more info on how Docker currently works on Windows and how maybe they're using it, and if they know anything solid about where it's going, then get in touch, ping us a tweet and what have you. We can include that in the show notes. The other thing, of course, is flipping it on its head. Can you run Windows inside Docker containers?
I think not.
I think not as well, for the same reason. Again, we're sharing this kind of kernel slice, and we
I think you can do it on
to
Windows, because I was looking at a Docker instance of MSSQL, for example, because I wanted to that would be like heaven for me, being able to run SQL Server headless on my Mac so that I can work on some client projects. But no, it only runs on Windows.
Now that, again, I mean, this is realistically, we are approaching kind of the apocalypse. We must be, because I'm currently running on my Mac this is a VM, this is not Docker, but it is running MS-SQL on Linux, right? That's a thing now. We have that. Yeah. So all of this stuff is kind of coming. Microsoft are catching up and what have you. But at the moment, I think it's pretty much safe to say that if you are a core Windows dev, if you're a .NET dev, if you're a SQL Server developer, then at the moment, Docker is something that you should pay attention to, be aware of, but it's probably not going to work brilliantly for you just yet. Right.
This is more for the... But I mean, does it matter? I mean... most of the time, I don't care that my application is running on Windows or on a Mac or on Linux. But then again, I'm working on a JVM, I guess. But
I suppose it also depends which way around you're looking at it. Can you install Docker on Windows? Yes, you can. You can reap all of these benefits as a Windows user, but it's on the understanding that you would have to be a Windows user working on something that doesn't require Windows on the server.
Right.
Yeah. Can you actually create Windows containers? Not so much. Again, if anybody knows different, please let us know.
And I guess what you could do is actually run your application on a Windows server running Docker, right?
Yeah.
Which goes on to the next part. Does it integrate with IIS, Apache, or does it contain that part inside itself? Well, it depends. Depends if you wanted to do that, because actually you have a container, images for Apache. So you have like a container that has Apache in it. As we've said before, it's like you can split it out, because why tie Apache to your application? Most of these people, I can't remember which Dave this is. It's not Dave Ferguson.
The other Dave.
The other Dave. And the whole point is that you don't want to tie Apache to itself. Like if you use Docker Compose, which is a great way to describe your environment, the whole environment, you can have load balancers in front of Apache load balancers or Nginx load balancers that then attach to your actual application. So you don't need to integrate it inside it. You try not to. You try to, keep it as isolated as possible.
And I think that, and again, this is an opinion, although strongly held. Probably the days of having this really tightly coupled relationship between your application layer and your web serving layer, and certainly Apache, I'm looking firmly at you and the traditional LAMP stack PHP.
Right.
That would be a module that was loaded in with Apache. People aren't doing that anymore. Right, yeah. I mean,
they're just proxying it.
People are doing it, but fundamentally they're either proxying it or they're using fast CGI connectors. They're using all of these different ways that you can decouple your web layer, because it means you can scale it. It means that you can move it up and down. You can swap it out. It provides better performance, better security, blah blah blah. Also, it means you can then use it in situations where you're using something like Docker and keep your layers nice and light, so you don't end up with this big ball of mud in your container.
And usually the big ball of mud is because of the Apache the web server trying to connect to your application, right?
Yeah.
These are most of the questions I see in the Lucy group, for example, is how do I connect insert web server to Lucy? And most of the time I'm going, what do you need the web server for? No one has actually answered that question to me. Like run Lucy on port 80, Tomcat on port 80, or run fine.
Yeah.
Does it? There's no need for a web server. It does HTTP serving pretty well.
It's I mean, I could make a point that I'd probably have a web server in production just to handle like the static assets, and there's a bunch of other bits I can do.
Right.
And yeah, I know I don't have to have it, but I would always want that additional layer. Also, it means that I can do more flexible things in terms of spinning up additional application backend if I needed to scale out. But
at least you're answering that question.
Well, yeah.
Not a lot of people can answer that question. It's like, because that's how the stack is, right? Like,
well, you've got to have a web server, right? We're doing web development. It's like you have a web server. You have a thing that's answering HTTP requests. And in the case of Lucy, it's a really solid stack. In the case of maybe some of the others, they've gotten scared by that whole, this is a development server, don't use this in production.
Right.
Yeah, the reality is actually, a lot of the time, you probably could. Don't, right? If you're a Rails dev, you shouldn't really be running your application on Rails S. But there's no reason why you can't proxy Rails S. It's not brilliant, but it would work. So anyway, the point is, disconnect your web server from your application.
Which leads us on beautifully onto Andrew's question. What are the options for autoscaling? Well, this depends on what you're deploying it on, right? So autoscaling, there is a load balancer. I can't remember the name of it. HA proxy, for example. You can just add that as a container, and it'll auto balance between your.
That'll auto balance. Will it auto scale?
Yeah, I don't know about
will it spin up additional Docker containers as needed?
Right. But they're so easy. Like, for example, with Docker Compose, they can be spun up easily by doing like scale, web equals however many instances. So I think this is where Kubernetes comes in, and Rancher and other projects. Like, for example, in AWS, you have the Elastic Container Service.
Yep.
Which you can also put a load balancing autoscaler, I think, in there.
You can. I mean, this is, I suppose, one of the things that I always get when people are asking about autoscaling, and this is the same whether it's VM or whether it's containers or whether it's just like boxes, is that fundamentally autoscaling is actually quite hard and it needs a whole bunch of tooling to do it right. Yeah. Not least of which it needs your application to be auto-scalable, which most of them aren't out of the box. But yeah, we wouldn't be able to talk about Docker without. My personal preference is that you will always have some kind of management system in production, right? Docker Compose is cool and it's groovy, and if you want to get started, it's great. At some point, you're going to need to actually have something that manages all of the containers you've got running, keeps an eye on them, generally health checks and all the rest of it.
I've been playing with Rancher, for example.
And I've been playing with Kubernetes.
Yeah, Kubernetes is the next thing to have a look at.
Yeah, I've got no idea how you pronounce that. It's a crazy name. Kubernetes.
Write in and tell us how you pronounce it.
Please do. In fact, don't write in and tell us how you pronounce something. That's crazy. Just send us a WAV file. But yeah, so either way, both of these things offer you a whole bunch of different tooling around management and provisioning. Kubernetes is Google's application, so this is actually, it's open source as well, but I think it's predominantly a Google project. And this is fundamentally what you get on their container engine. Amazon have got their own thing. Rancher I haven't actually used, but again, these will all have facilities to snap into kind of load monitoring and auto provisioning. They'll scale up, scale down, spin up, spin down, and they'll allow you to do that across different Docker hosts. So it's the options for auto scaling are fundamentally exactly the same as they are for current virtualization, only you get more flexibility and you can fit more containers on a given host.
I think this is a final question. Docker is a distraction for software developers. Discuss! Thanks, Simon, for that question. I don't think it's a distraction. It's something that you have to learn and then put it to the side and it just happens. It's the same thing as Vagrant was a distraction, I think.
I think it's an interesting question, not least to which, full disclosure, I know Simon really well. Simon's a really good software architect and really knows his stuff inside out and backwards. Okay. Simon's a good guy, knows his stuff, and I suppose the question is, we kind of get used to the fact that we've got a lot of different tooling, we've got all of this DevOps stuff that's kind of coming at us. If you're working in JavaScript, you've got framework changes, you've got all of this change and all of this tooling. And what I would, I suppose, be interested in is it easy to get distracted by the tooling in favor of actually making sure your software works, right, and is well written and well architected? To that I would say, yeah, absolutely. If you're dicking about with containers and what have you, but your software is still a pile of crap, you probably need to rethink your priorities, right?
Well, it depends what your job is as well and what you're trying to get. I mean, there's a lot of stuff that's changed over the last few years. I'm not even going to delve into the JavaScript changes because they're weekly. But if we look at other stuff like NoSQL, like deploying not on just on iOS and Windows, but actually doing in the cloud and having the ability to deploy and redeploy very quickly. The deployment is not an issue. The other part of it is like Jenkins, CI, and now Dockerization and containerization is sort of big topics that you should know about. There's a lot of stuff that changes all the time, but these are the big topics that you really should know about.
Yeah, totally.
Not 100%, or maybe someone in your company is doing it, or someone else is focused on the minutiae of it, but as a developer, you should know how that's happening, right?
Yeah. In the same way that you should understand how unit testing works and all the rest of it. I suppose to answer the question, is it a distraction for a software developer who isn't at the level where they're concerned with deployment or they're working as part of a big team? A junior developer just starting, should they dive straight in and learn Docker? Probably not. Actually, there are more important things for you to work on. Make sure that your code is clean, you're working to decent patterns, you're not reinventing the wheel, all of this. Learn a bit about security, learn a bit about unit testing. But at some point, especially if you're part of a smaller team or kind of a mid to senior developer, this should definitely be on your radar. It should be something you've maybe had a bit of an explore about. It's here to stay. It's not going anywhere. This is not a fad, not a flash in the pan. So to that end, Be distracted by it. Just don't be distracted by it for too long. This is not something that's shiny and distracting. This is something that's serious and useful.
And I think that's a great way to stop this podcast. And on that note, thank you for having tuned in. Next time, we shall be talking about continuous integration.
Continually.
And all its guises. So we're going to ask you to send your questions and comments to show@localhost.fm, or you can tweet us at localhostfm. I've been Mark Drew.
And I'm Rob Dudley.
And see you next time.